Hello, this is Professor Brown-Sederberg, and I'd like to talk about instances of a class. Here I've constructed a class. It's called Car. You'll notice that it has no main method. It is a class that's been written in order to allow us to create instances of it. So the name of the class is Car, and every car will have these four private instance variables. I've made the instance variables private, as we always should, because that allows us to keep control over those variables. That is, access to them, the change of them. So we should make our instance variables private. That requires us, if we do want to allow access to them, to create some methods, and we'll talk about that later on. But here we have these four instance variables: a string make, a string model, an int year, and a string color. We then have two constructors. Now you'll see that the first constructor is our default constructor. By definition, all constructors are public. They have a no return type, not even void, and they always have the same name as the class in which they reside. So here this constructor is public car. Now this is my default constructor. It expects no arguments to be passed to it. I have an empty parameter list. Now each and every constructor must give a value to each and every instance variable of that class. So here we have the make, model, year, and color all given values. Not yet assigned for the strings, 0 for this int. Those are the values given to each and every instance variable as this constructor is called. Now this constructor will be called when I create an instance and pass no arguments. Now, I also have this constructor, my non-default constructor. It is also public and named car, but it has this parameter list. It expects a string, an int, and a string, the make passed, the model passed, the year passed, and the color. It will take those values passed and store them into the appropriate spaces. Well, with make, model, and color, we store them directly. Here, for the year, I pass the value of the year passed into this method setYear, which is one of the methods of this class, and we'll look at it in a little bit. But this is our non-default constructor. When I create an instance of the class car, I will call this the default constructor passing no arguments, or this the non-default passing these four arguments. And I must pass them in this correct order, as the first argument accepted is taken as the make, the next the model, the next the year, and the next the color. They must be in this order in order to be appropriately saved. Now, we don't directly call constructors. They fire with the keyword new. So when I create an instance of this class, and I would do so with the line car, my car equals new car, that keyword new fires the appropriate constructor. If there are no arguments passed, this default constructor will fire. If for a string, an int, and a string, this one will fire. Now, you should always have constructors in your class, at least have this default constructor. If you have any constructor other than the default, say this one, you must have the default. So good practice is to have always a default constructor. If you want, have additional ones, but always have that default. Now, there are additional methods here. We have the method move forward, move backward, move right, move left, and those are things that a car can do. And they simply print to the screen forward, backward, right, and left. You notice that these are all public. You'll notice that they are non-static. They are non-static because I want them to be called by a specific instance of the class car, so that instance moves forward or backwards or right or left. So these are non-static methods. They're public, they may be called from the outside, but they must be called by a specific instance of the class. We then have the getters. Now getters, also known as accessors, are methods that allow us to get the values of the instance variables. And getters are included in your program, in your class, if you think they're appropriate. I've put getters in for each one of our variables. And I have to have these getters if I want anyone from the outside access to any of the instance variables. I've made those instance variables private, so they can't be accessed directly from the outside. I therefore must provide methods, and here are the methods, the getters, that allow a user to call the method, and that method will provide them access to the appropriate instance variable. You notice that all of these are public. They are also non-static, which means they must be called by an instance of the class. That makes sense. I want the make of a specific instance, the make of a specific model. I'm sorry, of a specific instance. So each one of these are specific to an instance. We then have the setters, and the setters are methods that allow us to set the values of our instance variables. If I want the values of the instance variables to be changed, I must provide setter methods if those instance variables are private. And in this class, all of our instance variables are indeed private. So here I have set make, set model, set year, set color, right? And they provide us a way to change the value of those instance variables. You notice that these are all public. They're also void. They don't return anything. They just accept something in and save it. Now, they're also non-static because I'm setting the make or the model or the year or the color of a specific instance of the class car, of a car. You notice that each one expects an argument to be passed to it. And in these three, this one, and this one, and this one, I simply take the value passed in by the user and to this method and save it. In this method right here, set year, we do test to make sure that the year is indeed of an appropriate value. If the user gives us a number less than or equal to 0, the year is set to 0. Otherwise, it's to the value passed in. So these are my setters. Setters are also known as mutators. Our getters are also known as accessors. Now I've put in getters and setters for each and every instance variable. You don't have to do that. That's a matter of what's appropriate for your program. You'll see that I have a method toString. Now toString will return a string, and this method is always public and it's always non-static, and it should be toString, lowercase t, uppercase s, and this overrides a toString method that's inherited by any class from the superclass, the mother of all classes, and that's the class object. We should always have a method toString. It takes no arguments, and what it should return is the value of the instance variables of that instance. So here I return back the make, model, year, and color, and I return back a string. This method always returns back a string, and I've added these titles to what I'm returning back. So this is the method toString. I also have this method equals. We should always have an equals method, and what the equals method does is compare the values in the instance variables of the instance that called the method to the values in the instance variables of the instance that was passed. So this method, you'll notice a non-static method, will be called by a specific instance of the class car. It will receive another instance of the class car, and it will then test to see if the make, model, year, and color of those two instances are equal. Now this, remember, that keyword refers to the instance that called this method. So on this line, I will put into the Boolean space are they equal that was declared here what is returned when I compare the make of the calling object to the make of the past object, the model of the calling object to the model of the past, the year of the calling to the year of the past, the color of the calling to the color of the past. And so this will test to see if those values are equal, and if they are, it will set are they equal to true, are they equal is return back. If they're not equal, are they equal is false, and that's what is returned back. So here we have a class, the class car, and I've put it together in order to create instances of this class, to create specific cars. Now this class will not run because it has no main method. We'll call this class, we'll call the methods of this class from another class, and we have it here in this class, Demo Instances of a Class _ Car. Now in this class I have a main method, and I intend in this class to create instances of the class car and manipulate them. So you'll see here I have created my cars. I have created a car C1, C2, C3, and C4. And we declare them here and create them with this new. This keyword new fires the constructor, and I'm creating a new car. Here we're calling the default constructor. Remember that the default constructor puts values into each and every instance variable, not yet assigned, and 0. I here create a new car, C2, and make it a BMW 325 Ci. I've tried to pass -900 as its year and the color black to its color. We know that the method that it sets the year will set that to 0. We'll look at that. And then we've got a Volvo and a Porsche. We've passed those values along. Now, in this next line, these next lines, I am going to print the values stored in these instance variables as passed here, as I created the instances of the class car, and I'm going to do that with the call to this method toString. So I will have C1, C2, C3, and C4 call the method toString. That method will return back a string that is the year, make, model, and color of that specific car. So it'll be car C1, C2, C3, and C4. Let's run this program, and we'll see what's printed to the screen is indeed the original cars. And we recall that the first car, it was the default constructor, so not yet assigned, etc. My second was a BMW 325 Ci. I tried to pass 900. We know that that method will substitute 0, and the color is black. Then I have my Volvo, and I have my Porsche. So here we've called the method toString. Now, when we talk about instances of a class, when I create an instance of a class, as I have in any of these 4 lines, what is stored in the space C1, C2, C3, C4 is an address. An address that points to a space in memory where these instance variables are stored. So C1 stores an address. And we can see that here in these next few lines. What we've done in these next few lines, and let me just put this in, is I am going to swap 2 cars. I am creating an instance of the class car, and I'll call it temp. I will put the value that's in C1 into temp, the value in C2 into C1, the value in temp into C2. So I have swapped C1 and C2. The value in C1, that address, was stored in temp. The address in C2 was written into C1. The address that was originally in C1 is now in C2. Now we remember that C1 is our default and C2 is that BMW. I'll now print out the values of C1, C2, C3, and C4, the instance variable values, through this call to toString. So let's run this program now, and we see that we have our original values of C1 was our default, and then C2 our BMW. And now we'll see that they've been swapped. I have swapped the values of C1 and C2, that is the addresses stored in those spaces. So when we work with the variable names C1 and C2, those are address spaces. If you want to swap values between in those spaces, you'll do so this way, creating instance of the class car, storing the value in C1 into temp, C2 into C1, and then temp into C2. Now, if in those spaces C1 through C4 we have addresses, what can happen is you can orphan an object, that is, lose the address. So let's look at these lines. And what I've done is I've said I want to put into C1 what's in C2. The address of C2 will go into C1. I'll then print out the values of C1, C4, and C1 as they're compared to C2, C3, and C1. So here I have put into the space C1 what's stored in C2. And then I'm going to try to see if those two are equal. All right. So let's compile this, run it, and we'll see that we have the answer of true, false, and true. It is true that C1 equals C2. It is false that C4 equals C3, and here I've asked again, is it really true that C1 equals C2? Yes, it is. If I were to compare, if I'll change this and let's compare C3 to C2, we'll run it again, and that last should be false, and that's what I expect. So here I have the value stored in C2 is now stored in C1. If I were to try to find the values of C1, I can't. That address has been lost. That's orphaning off an object. So it's important for you to understand that when we're dealing with instances of a class, the named space stores an address, not the values of the variables, but an address that points to those variables. Now, let's comment out some of this, leaving our original cars as we have them. And so we'll comment from here down to here. Let's look at calling some of the methods that we have here in car. We know that our constructors have been called with that keyword new. Now I can have any of the instances call any of these methods. They're all public, but they must be called by an instance of the class. I can also call my get make, model, year, and color, and my setters, my set make, set model, set year, and set color. Now we've already called toString, and we've already called equals. If I were to call one of those methods, let's set a new value for one of my cars. Well, my original car, C1, has no values to it, so let me call or have C1, and C1 is our instance. We'll have C1 call the method set color, and we'll set that color to be, let's make this car blue. We'll have C1 call the method set year, and we'll make this we'll make it a 2013. We'll have C1 call the method set model, and we'll have it be a we'll make it a Ford. And then our last would be we have our color, we have our make. Now we oh, I'm sorry, model is not, model should be, that should be a make, sorry. And we'll have the model be I don't know, give me a Ford, we'll make it a Mustang. Not even sure if they still make those in 2013. If I were to then call toString, that is have C1 call toString, and pass that to println, we'll see now that my values of C1 are a Ford, Mustang, 2013, and blue. So I'm able to call these methods in car because they're public. I must call them using an instance because they're non-static. Were I to attempt this, to say car.setColor, I would be yacked at compile time, because setColor is a non-static method, and that makes sense. I want to set the color of a specific car. So this has been a brief introduction to methods in a class, the use of those methods, the construction of those methods, specifically our constructors, our getters, our setters, our toString, and our equals, the creation of our instance variables, the declaration, they are private, a type and a name. They are specific to an instance of this class. And here we've seen the creation of objects, the calling of objects, the use of objects, etc. You will use classes that provide the blueprint for instances quite a bit in Java. That's the object orientation of it. That's part of that whole paradigm of object orientation. Every instance of a car is an object. It's a thing. And every car has the same variables. That is, they have a make, a model, a year, and a color. They have the same capabilities, the methods that we have in this class. When I call those methods, I call them specifically for that instance by that instance. They must be called by that instance because they're non-static methods. That makes sense. So this has been a quick demonstration of classes, instances of classes, objects.